when I'm gonna work out a problem like this, I usually do an XY chart, as everybody in here knows. So the first thing I'm going to do is I'm going to rewrite this in exponential form. It'll be easier for me to look at an XY chart if I do that. Now, when I rewrite this in exponential form, the base is 5, and you should see your notes about that. I mean, that is kind of a plug and chuggy kind of thing where you're looking at how things fit together, and we're not going to develop that here because we already did that in class. But basically this says 5 to the y, remember, equals x. This is always the exponent. And so that's how that's going to look. And then I would start out by plugging in values for y. So that's a little different, but that's just the way it goes. So maybe I might plug in, I don't know, -1, 0, 1, and 2. When y is -1, x equals 5 to the -1. That's 1/5. When y is 0, x equals 5 to the 0. That's 1. When y is 1, x is 5. When y is 2, x is 25. So at least I have some points there. Now if I'm going to look at my graph, I see that when I might have to, oh, that's good enough. I see that when x is 1, y is 0. So I might put that point on there. When x is 1/5, when x is 1/5, y is -1. It's like right there. When x is 5, y is 1. And I think this gives me, because I remember the general pattern that took place, a pretty good idea of what that looks like. So this is y equals log base 5 of x. Now if I want to look at the other graph, it says how is that the same or different from y equals log base 5, only this time it's x plus 2 in parentheses. So this time when I rewrite it, 5 to the y equals x plus 2. I see that there's a little something different going on here. Personally, I would probably subtract 2 from both sides, but you don't have to. It just might make it a little bit easier before I make the XY chart. Now when I look at the XY chart, again, I'm going to plug in values for y first, and I'm going to go ahead and solve. I see that it's going to be kind of the same because I still have 5 to the y, which I had up here. Only now I'm going to be subtracting 2 from each of these. So for example, let's start out with the 0. 5 to the 0 minus 2 is 1 minus 2. Okay, 5 to the 1 minus 2 is 5 minus 2. 5 to the 2 minus 2 is 25 minus 2. All right, so let's take a look at what that looks like. And I'm just going to stay on my same set of axes. So I'll just move this over here so I have access to it. And I'm going to take a look. So when x is -1, y is 0. When x is -1, y is 0. So now that's over here. And when x is 3, y is 1. When x is, oh, the next one I don't want to do when y is 2 because 23 is. So I'm guessing that it's the same one, only it's shifted over to the left 2. So you see how it's this same graph that I had for y equals log base 5 of x, only it shifted over 1, 2. Okay, so hopefully that all made sense. Now you can work on the closure problems. There's also some closure problems from chapter 7 that you should work on that we haven't looked at yet. So I'm going to also write those up there. But good luck, and I will see you guys for the test on, well, actually, um, yeah, and don't worry about the closure problems from Chapter 7. I'll try to get them to the sub by the time you guys work on this, but I don't think that'll be critical. Team Test Friday. See you then. Have a good rest of the